Welcome back. This is Nick Agram. I will be discussing the factorial notation. It is imperative for our study for the binomial expansion. Definition for n factorial is for n greater than or equal to 1. That is, n factorial is the product of the first n positive integers such that n factorial is equal to n multiplied by n minus 1 multiplied by n minus 2 and so on and so forth. Let's give an example to this. It says here, so for example, I have 5 factorial. That means it is 5 times 4 times 3 times 2 times 1. Because I will decrease by 1 all the time. So 5 minus 5, that is n. 5 minus 1, that is 4. 5 minus 2, 3, and so on and so forth. Okay, but general notation for n factorial is this. N factorial is equal to n multiplied by n minus 1 factorial. So I can actually write 5 factorial like this. 5 multiplied by 4 factorial. Or I can write like this. 5 multiplied by 4 multiplied by 3 factorial. I can do that. Okay? And then we have this 0 factorial is equal to 1. I'm not going to prove. There are a lot of ways to prove this. You can watch them in YouTube. But I'm not going to prove it. I'm going to show you a pattern which shows why 0 factorial is equal to 1. I think that is the best explanation that I got. We're going to use this. It says that we have n factorial is equal to n multiplied by n minus 1 factorial. That means n minus 1 factorial is equal to n factorial divided by n. Because if we divide both sides of the equation by n, then this will become 1. Okay, so for example, I will start with 5. So I have 5 factorial is equal to 5 multiplied by 4 factorial. That means it is also 5 factorial divided by 5 is equal to 4 factorial. Then I have 4 factorial is equal to 4 times 3 factorial. Or I have 4 factorial divided by 4, that is equal to 3 factorial. As you can see here now, there is a pattern, but I will show you another. 3 factorial is equal to 3 times 2 factorial. That means 3 factorial divided by 3 is equal to 2 factorial. So if I'm going to have 2 factorial now, the pattern is like that. Divided by 2 is equal to, as you can see here, n factorial divided by n. Then I will get 1 factorial. Then if I have what do we have now? 1 factorial divided by 1 is equal to 0 factorial. If we follow this, 4 factorial, 3 factorial, 2 factorial, 1 factorial, 0 factorial. Then we have 1 factorial divided by 1. 1 factorial is equal to 1. As you can see here now. That's 1 times 1. Then we have now 0 factorial is equal to 1. We've shown this by sorry for that, by using a pattern. I didn't prove it. I just showed it that this applies. Okay, so it's good to understand these two. They are important. Okay? So for example, we have 3 examples here. What integer is equal to 4 factorial? Then we have our a here now. We have 4 factorial. That is equal to 4 times 3 times 2 times 1. That is equal to 24. That's 12 times 2, that's 24. Okay, b, we have 5 factorial divided by 3 factorial. Then we have 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1. As you can see, this will become 1, then we have only 20. There is another way to solve this. Remember the definition, n factorial is equal to n multiplied by n minus 1 factorial. We can use that definition. For example, 5 times 4 times 3 factorial divided by 3 factorial, because you have already 3 factorial there. Then we have the same answer, 20. Okay, C. We have 7 factorial divided by 4 factorial multiplied by 3 factorial. Then we have 7 times 6 times 5 times 4 factorial. We can use that. And then we have 4 factorial multiplied by 3 factorial. Then we have 4 factorial will become 1. Then we have 3 factorial is 3 times 2 times 1. That is 6. Then that will become 1 also. Then we have only 35. So I hope you learned something once again for factorial notation. And in my next video, I will be discussing, like what I said, this is a prerequisite for the binomial coefficient. Then I will be discussing that in my next video. And thank you for watching. Have a nice day.